Welcome, ladies and gentlemen, to your MN2 notes, where we're going to talk about parallel and perpendicular lines. This is section 3.5 in your textbook, if you want to use that as your cross-reference. Before we get into the perpendicular and parallel lines themselves, we're going to first go and do a little bit of a warm-up here. It says in the warm-up, name the slope and y-intercept, and then graph each of the lines. So we have two different lines here. The one on the left here, number 1, it's y equals 2x minus 5. Now, this is already in slope-intercept form, and from last year, you guys would have talked a lot about y equals mx plus b, where m is your slope. So I'm going to put that 2 over here. That's your slope. Notice I'm not saying 2x. The slope is 2. That's the number in front of the x value. And really, I'm going to put it over 1. Because when we deal with slope, we do rise over run. And if it's written as a fraction, it's much easier to graph it. The y-intercept is right here, which is -5. So I'm going to put that right here. So again, if your equation already is in slope-intercept form, it's nice because the slope is just right before the x, and the y-intercept is out back, either, in this case, a -5. Now, this here is the x-axis, this here is the y, and if we have a y-intercept of -5, we go down 1, 2. Now, the scale on here, this graph paper, I think, is going down by 2s, but I'm going to do by 1. So -1, 2, 3, 4, 5. This right here is -5 on my y-axis. And then I'm going to use my slope, which again is 2 over 1, with the understanding that it's rise of 2 and a run of 1. So I'm going to rise 2 right here. So I'm going to 1, 2, and I'm going to run 1. So my point is going to be right here. I can do that again. Rise of 2, run of 1. Remember, slope is all about steepness. It's your rate of change. And in this case, we have a nice steep slope, positive slope of 2. So that is the graph of that line. Now over here on the right-hand side, we have an equation 5x plus 4y equals 8. You notice it is not in slope-intercept form. This is actually standard form. This form is really nice to graph by using the x and y intercepts, or the zeros. But because we're asking for the slope and the y-intercept, I'm going to go through the steps of putting the standard form into the y equals mxb or slope-intercept form. So in order to get it into that y equals mx plus b form, I'm going to first move this 5x right here over to the other side of the equation. So I'm going to subtract 5x from both sides. And this equals 0. I'm going to bring down the 4y equals, and then I'm going to have -5x plus 8. Now I'm not completely in slope-intercept form yet because I have a 4 multiplying that y, so I want to undo that by dividing both sides by 4. And this is really important. What you do to one side, you do to everything on the other side. Make sure you don't miss a term. So we have y equals, my slope is -5 over 4x plus, and then 8 over 4 is equal to 2. So now this right here is slope-intercept form, where this right here is the slope, and this right here is the y-intercept. So up here, the slope is -5/4, and the y-intercept is 2. So I'm going to start, and I'm going to actually change colors just so I don't have to erase any of my purple or bluish work right there. I'm going to switch to green so you can see my actual graph. My y-intercept is always the starting point, and my y-intercept is 2, which is right here. And then because we have a slope of -5/4, and remember I had said this is rise over run. The problem is we have a negative here, so we're going to go downhill with this line, and instead of rising 5, we're going to instead go down 5 because of that negative. So 1, 2, 3, 4, 5, and I'm going to run 4. And always I run to the right, so I go either up or down depending on whether I have a positive or negative slope, and then I always run to the right. So 1, 2, 3, 4. So when you get really good, then you sometimes run to the left, but initially it is very good idea to just kind of make sure you get the initial slopes down. Okay, so this is a y-intercept of 2. Notice it's supposed to hit here at 2. And then we went down 5 over 4, so we have a negative slope of -5/4. Okay, that is definitely a review from Algebra 1. Hopefully a good review for those of you who might be a little rusty with it. We're going to get to the key ideas of this note guide, which is the very first one on the left-hand side. It says key idea. If two lines never cross, they are blank lines and their slopes are blank. Okay, so if two lines never cross, they are parallel, folks. If they never cross, they're parallel. Ooh, geez Louise. That's why I try spelling it right. Sorry, folks. Oofed. Parallel, P-A-R-A-L-L-E-L, lines, and their slopes are, you could say the same, you can say equal. I'm going to use the word congruent. And that means, in math terms, the same. Oops. Oh, geez. I just erased a whole bunch of stuff here. Hold on. The same. We're going to be using that word a lot, congruent. Over here on the right, okay, so again, parallel lines, if your lines never cross, that means the slopes are congruent or the same, and vice versa. If you have the same slopes, then that means that the lines will be parallel. The key ideas over the right on the right-hand side is if two lines cross at a right angle, which it means 90 degrees, they are called perpendicular. P-E-R, perpendicular. That is 13 letters, just so you know, to spell the word perpendicular, which is why I tend to use this symbol right here for perpendicular. This is the same thing as saying perpendicular. So if two lines cross at a right angle, 90 degrees, they are called perpendicular lines. And their slopes are, and this is a pattern that's really, really important. They are opposite signs, reciprocal. Oops, again. Reciprocal. Okay, R-E-C-I-P-R-O-C-A-L. Opposite just means the opposite sign. Reciprocal, another way to think about it is the flip of the fraction. So the flip. So I'm going to go back to the first key idea over here with the parallel and the congruent or the same slopes. If you have, oh, by the way, parallel, instead of using the word parallel, you can use this symbol, which is two lines next to each other, not crossing. That's the symbol for parallel. Over here on the right-hand side, that was the symbol for perpendicular, just kind of shorthand. So if you have a slope of 1/2, the parallel slope is going to be 1/2. Ooh, 1/2. I just really want to say 11. On the right-hand side, if I have a slope of 1/2, the perpendicular slope is going to be the flip of that, which instead of 1/2, it's 2/1. And this first one is positive, so this one's going to be negative over here. So they're going to have opposite signs. One's going to be positive, one's going to be negative, and they are flips or reciprocals of each other. So those are two big key ideas, and we're going to use those down here in example 3 and 4. For the first one, 3 is dealing with parallel lines, and the second, number 4, is going to be perpendicular. So here it says in number 3, write the equation of the line that goes through this point right here, 5/8, and is parallel to this line right here. Now, again, you notice it's step 1, 2, 3, just like our note guide 1. And so we do need to find the slope. Now, we saw in the key point above that the parallel lines have the same slope. So if I can figure out what the slope is of this line, then I have already my slope for step 1. Now notice it's in standard form. We need to switch that over to slope-intercept form. So we have 2x plus 4y equals 8. So to get it into that y equals mx plus b form, slope-intercept form, we need to move the 2x over. I have 4y equals negative 2x plus 8, and then I divide out by 4. So here I have 1y, or y, equals negative 2/4 is the same thing as negative 1/2 x plus, instead of 8 over 4, it's 2. So this is the equation of that line in slope-intercept form versus standard form. Again, this right here is the slope of this line, and this over here is the y-intercept, which, by the way, we don't care about because that is not going to help us with our actual problem. We're only interested in the slope because the slope of parallel lines are the same. So over here, step 1, what is the slope that we want? Well, negative 1/2. Why? Because that is the slope of the line that we want to be parallel to, and they are the same. We're congruent. Step 2, find the y-intercept. Well, we start with, just like in our MN1, we start off with our general form. We put in our point up here. Now remember, this is an xy coordinate point. So we have 8 equals slope of negative 1/2 from step 1, and the x-coordinate is 5 from our original point, plus b. So again, this is our x point right here, and then our y point is 8. We're substituting in just like, ooh, geez Louise, just like we did, oh my goodness gracious, this in our MN1. I am clearly not in sync here with my smartboard. Okay, we need to solve this. So we have 8 equals negative 1/2 times 5. You can either say it's negative 5/2, or you can convert it to a decimal and say it's negative 2.5. Now up above I had said it's nice, this is by the way a plus here, it's nice to have the slope as a fraction. The y-intercept truly does not matter. Actually, it's almost easier to have a slope as, or the y-intercept as a decimal, because you have to graph it somewhere on that y-axis. So negative 1/2 times 5 is negative 2.5. I'm going to add that 2.5 to both sides. So I end up with a y-intercept of 10.5. Okay, so we have this component, which is my y-intercept. That's where I'd start on the y-axis. And then this is my slope, which is where we go down 1, run 2. So the equation altogether for the parallel line is y equals negative 1/2 x plus 10.5. So that, my fine young ladies and gents, is the answer. Okay, so really the parallel lines, it's very much like our MN1, find the equation of a line through 2 points. The only difference is we need to find the slope, and the slope is going to be the same as the line that we want to be parallel to. Now perpendicular lines, hate to say it, not necessarily as straightforward, and some students really struggle with that opposite reciprocal component. But let's just look at this. It says write the equation of the line that goes through this point, negative 1, 3, right here, and is perpendicular to this equation, y equals negative 1/4 x plus 11. Now again, this right here, folks, is the slope. The y-intercept in this problem initially does not matter because that is the line we want to be perpendicular to. We're not going to be using that y-intercept. We are only focusing on that slope because that's, we use our pattern to find the slope of the line that we actually want to have the equation of. So if this slope is negative 1/4, that means it says find the slope we want. Well, we're talking about perpendicular slope. So if this is originally negative, I'm going to write this a little clearer. If it's originally a negative, now it's going to be a positive. Instead of saying 1/4, it's going to be 4/1. So it's going to be a positive because the other original was a negative, and instead of 1/4, it's going to be 4/1. Opposite reciprocal. So this is the slope we're interested in right here, this one right here. I'll circle it just so we remember that's the one we're interested in. The other slope was for the line we want to, that's perpendicular to the one we actually want to find. The y-intercept, same as what we've been doing over and over now. I think you're starting to pick up on that. Y equals mx plus b. Start with this slope-intercept form. We have the point up here that's given to us. That's going to be put in down here. So we put 3 in for y. Our slope that we just found, x is -1 from, again, that point at the original, at the beginning of the problem. And we have 3 equals -4 plus b. I add 4 to both sides, and I end up with b. I'm just going to write right down here. B is equal to 7. That is our other component. Remember, we need 2 pieces to put the puzzle together. Now step 3 says put the pieces together. Well, we have y equals mx plus blank. We know our slope is 4 because we found if you want to write it as 4 over 1, that's absolutely great. And the y-intercept is 7. So y equals 4x plus 7. This is the line that's going to be perpendicular to that y equals -1/4 x plus 11 that we initially looked at, and we'll go through the point -1, 3. So this is how we find parallel and perpendicular lines, and we'll take any questions you have tomorrow in class. Thanks for tuning in.